Hello everyone, here is the beginning of the third chapter in our chemistry class. It's on atoms, which are of course the building blocks of matter. Everything is made of atoms. So let's start looking into some of the early philosophy on how we got the atoms. Okay, so as far as class objectives go, at least the section objectives, let's take a look at this right here. This is what we're going to look at. We're going to look at the philosophy to theory. So this is actually just a quick video on this. We're going to explain three fundamental laws that were actually in place before they went through all this. And then we're going to talk about Dalton's atomic theory. You really should know those. And then we're going to talk about modern atomic theory and how it came about. Okay, so initially we had no experimentation, just philosophy. So in the beginning there were no experiments, like I said, just philosophies, and there was actually a debate between two gentlemen, one by the name of Democritus and one by the name of Aristotle, which I think you've heard of him. But Democritus, basically to make this a little bit more concise, he thought that matter, you could cut matter over and over and over again, and you take the halves and cut those in halves and cut those halves in halves and so on and so forth, and you'd end up getting the smallest indivisible, indestructible piece, which he believed, or at least the word comes from the Greek word atomos, in other words, the atom. Okay, that's what Democritus believed. Aristotle says, no, no, no. You can keep cutting matter over and over and over again and take the halves and cutting those halves in half and so on and so forth, and not have any, and never terminate. It just goes on and on forever. Okay? As you can see here, this idea of Aristotle was accepted for 2,000 years. Okay? That matter was continuous, that it kept going on and on. Okay? Now, so for 2,000 years, this persisted, and then finally by 1790, again, these natural laws come into place, which we're going to talk about shortly. But everyone agreed that finally that the matter was indivisible was adopted. Everyone agreed that that the atom existed, that you could keep cutting matter only to a certain point, and that you would have a single atom. Okay, why? How did this come about? Well, there was huge improvements in balances. See, there wasn't technology in 1790. There was, but it wasn't very advanced. So what they did was all they had to use was double pen balances. Okay, at least that was the majority of their work. And then now the research moved to measuring quantities. Instead of just philosophizing and thinking through things, they were able to actually measure things, and now we get some of these basic laws. Okay, the three basic laws are these. The first one is called the law of definite proportions. Now, it says a compound has the same elements in exactly the same proportion regardless of quantity. In other words, I could have a bucket of water, I could have a drop of water, I could have an ocean of water, but it all is based on, again, this is mass, but it's all based off of the fact that there are two hydrogens and one oxygen. Okay? So we see here two hydrogens to one oxygen. It's always a 2-to-1 ratio no matter how much you have, no matter where you get the water from. It could be Earth, it could be the ocean, it could be the moon, it could be Mars, whatever it may be, or somewhere outside the solar system. Again, it's always H2O. And the example that I give you here is carbon dioxide is always CO2 no matter where you go or how much you have. The second law, it's called the law of multiple proportions, and this is actually kind of a little bit more of a difficult one to understand. But basically, if I have two compounds, and they're composed of the same two elements, then the ratio of the masses of the second element combined with the first, 1 gram of the first element is always a ratio of small whole numbers. So here's the definition. Here you see you have water, okay, H2O, and this is something called hydrogen peroxide. So you have two elements, 1, 2, made of the same two elements, hydrogen and oxygen. And you'll notice that the ratio of the second element when compared to the first, 16 to 32, always was whole numbers. So this is 2 times that 1, okay? So when we see here is this is a 1 to 2 ratio of hydrogen to oxygen, and this is a 2 to 1 ratio here, okay, or the ratio of oxygen between the two. Okay, so this is the law of multiple proportions. Okay, so again, when we deal with the same amount of hydrogen, the oxygens vary by a factor of double. Okay, in this example, there's many examples. This is just one of them. The last and probably most important for us is something called the law of conservation of mass/matter. And basically it says that matter can't be created or destroyed during a chemical reaction. You can only take matter, disassemble it, and then rearrange it into other things. Okay? So when we have matter and we want to conserve it, it's, for example, if we take a very simple reaction, we take some hydrogen gas and react some oxygen gas, you're going to get some water, okay? Now, if I start off with a balanced amount of this stuff, okay, if I have 4 hydrogens, you'll end up with 4 hydrogens. Now, how I got 4 hydrogens in the math is a little bit, let's work on that a little bit later. These are 2 oxygens, these are 2 oxygens. So you notice 4 went to 4, okay, that means it yields 4, and 2 oxygens went to 2 oxygens, okay? So whatever I put in comes out, okay? If I were to put in 2 kilograms of reactants, I will get 2 kilograms of product, okay? I won't end up with double the product or double the mass of product. You'll end up with the same amount, okay? So whatever you combine here, if this is 2 kilograms, this is 2 kilograms, okay? That's the law of conservation of mass and matter. And again, let me reiterate, what you do during a chemical reaction is everything is broken apart, just disassembled, and then rearranged into something completely different, okay? I'm sorry, it resembles the original pieces, but the overall physical and chemical properties of that new product are completely different. And we looked at that in chapter 2. So along comes the Dalton's atomic theory. We're not at modern atomic theory yet. You can read through these just like I can. Matters are composed of tiny indivisible things called atoms. Atoms of the same element are identical. Point number 3 says atoms of different elements combine in small whole number ratios to form chemical compounds. That's when I was talking about water of H2O. That's a 2-to-1 ratio. And finally, in chemical reactions, atoms are combined, separated, or rearranged, but never changed into atoms of another element. So chemical reactions, again, let me say it for a third time, you take what's there, you disassemble it, and you rearrange it into something completely new, but you never create new atoms, new elements, okay? Now, as good as Dalton did, and I believe he did his work in around 1808, as good as he was, and as good as in 1808, this is really good work. He was wrong 2 ways. Okay, and the 2 ways he was wrong is in red now. Okay, so you see it's an identical slide, but I changed it to red because the indivisible particles, we know that atoms are divisible now, but you can split an atom. He didn't know that. And the second thing is that all atoms of the same element are identical. They're really not. There's one issue, and that's called isotopes. Isotopes are atoms of the same element, but they have different masses, so they're not identical. And so atoms, yes, are identical in the number of protons they have, but other than that, some atoms of the same element can be heavier than other versions. We'll talk about isotopes a little bit later, okay? So now we get into modern atomic theory, which basically says that all atoms are composed of the same elements. Let's see here, will that pop up? Okay, so anyway, modern atomic theory basically says all these things that Dalton said, but make those 2 changes and we got it. Okay? All right, that's it for the first video for the first for chapter 3. More on this later.